All right, you guys, let's go ahead and look at this review I gave you, 7.4 review. Okay, so find the particular solution of, and then it gives me this equation. All right, and the point y of 2 equals 5. Now I'm going to need a little bit more room than what's on here. So I'm going to come over here and go 4. Remember y is dy dx, and that's 3x squared plus 2x, and y of 2 is 5. Okay. So first, let's go ahead and separate my variables. I want the dx to come up here, and any y's to go down there. There's not any, so that's fine. So it's just 4 dy equals 3x squared plus 2x dx. Okay, I'm going to go ahead and integrate both of those. So 4y equals, now this is going to become x to the third over 3, which will cancel out. And this one's going to become x squared over 2, which will cancel out. Okay, plus my constant. All right. Now I'm going to, I think I'll go ahead and solve for y first by making a 1/4. Well, no, you know what? Darn it. I don't want to have crazy fractions when I do this. So I think I'm actually going to solve for c first. Okay? I think that'll just be a little bit easier. So it tells me that y equals 5 when x is 2. So 20 equals 8 plus 4 plus c. So c equals 8. Okay? So I get, so I'm coming back to here, right? And I get, okay, 4y is x to the third plus x squared plus 8. And then basically to solve for y, I'm just dividing everything by 4. You can write it with a 1/4 out front. You can put this whole thing over 4, however you want to do it. Okay, but that's the answer for that differential. All right, let's look at the next one. Okay, guys, for the next question, find the particular solution of, this one says dy dx equals x over y if y of 5 equals 3. All right, nice. Let's check this out. Okay. Separating my variables. So I want to go ahead and bring my y up here, my dx up here. Okay. So I have y dy x dx. Here we go. I'm going to integrate both of these. This gives me y squared over 2. This gives me x squared over 2 plus a constant. Okay, I'm going to multiply everything by 2 right now. So I get y squared, it's x squared plus a constant, different constant. We've talked about this a bunch. All right. Okay. And I think I want to solve it here, actually. Right now I want to solve for c. So this is saying if x is 5, y is 3. So 9 is 25 plus c. So c is negative 16. All right, c is negative 16. So I'm going to come back up to this one. I'm going to say, okay, y squared equals x squared minus 16. Go ahead and solve this by square rooting both sides. So I know that y would be plus or minus the square root of x squared minus 16. Okay? And then I have to decide which one I pick. Well, if I come up here, it says if I plug in 5, it wants me to get a positive 3. If I plug in 5, so 5 squared, that'll be 25 minus 16. To get a positive 3, I'll just need to pick the positive one. So then that's my answer. Okay, positive x squared minus 16. Obviously, you don't need to put the positive there, but you guys get the idea. Okay. Ooh, this looks fun. All right. Y prime, find the particular solution for y prime, which is dy dx over 3x squared equals my minus 1. Y of 0 is 5. Okay. Move this up. First, I'm going to do this in kind of 2 separate steps because they wrote it weird. So that's 3x squared y minus 1. And then I'm going to move the dx up and the y minus 1 down. Okay? So dy over y minus 1 is 3x squared dx. All right, perfect. Okay, let's go ahead and integrate both of these. You guys, this is an ln problem. This is an x to the third over 3 problem, okay? Plus a constant. Yeah, I think I am going to use this right now. I think I'll go ahead and plug in 0,5 right now. So what it's saying is that if x is 0, c is going to be the ln of 4. I could drop the absolute value because 4 is positive. So c is the ln of 4, okay? So I'll come back up here. I go the ln of y minus 1 is x to the third plus ln 4. Writing too big. Here we go. Plus ln 4. Guys, to get rid of an ln, you e both sides, right? It's not really a thing, but you e both sides. So y minus 1 is e to the x to the third plus ln of 4. But if you remember that adding in the exponents means it's actually e x to the third times e ln 4, and the e and the ln cancel out. So y minus 1 equals, I'm going to go ahead and bring this 4 right there. Okay, it equals 4e to the x to the third, and then I'm going to add 1 over. Okay, there's my equation. All right, now let's jump onto here. Which of the following differentials is represented by the slope field shown? Okay, you guys, if it gives you in your multiple choice a dy dx, it's talking about the actual slopes, not like the way that the graph goes, but the actual value of the slopes. So I'm going to start looking for some patterns. Now, on number 4, the first pattern that I see is right here. Do you guys see that all of those slopes are 0, 0, 0, 0, 0, 0, 0, 0, 0? Okay, and those are points like 0, 0, 0, 1, 0, 2, 0, 3. When x is 0, all of my slopes are 0. So, if x is 0, are all those slopes 0? A, yes. If x is 0, are all those 0? Yes. If x is 0, does that make all of those 0? No, because it's y squared, so no. Okay, if x is 0, does that make all those 0? Yes. And if x is 0, does that make all those 0? Yes. Well, that's really annoying, because that only narrowed it down by 1. Okay, what else am I seeing? Ooh, this is interesting. Okay, I like this. Now you guys, your brains may go somewhere else, but this is what I'm looking at, right? Those are all zeros. And let's look at what points those are. Okay, that's the point negative 4, 4. That's the point negative 3, 3, negative 2, 2, negative 1, 1. And then it's 1, negative 1, 2, negative 2, 3, negative 3, and 4, negative 4. Those are actually along the line y equals negative x. So when y equals negative x, it's all zeros. Okay? So let's see if I could figure that out. If y is negative x, are those zeros? No, it looks like those are x times 2x, so no. If y is negative x, are those zeros? Heck yeah, that one's still in the running. If y is negative x, are those all zeros? Nope, those all look like undefined. And if y is negative x, are those all zeros? Nope, that looks like negative x squared, so then I got it. Okay, so I always look for where it's either undefined or 0, kind of help me figure it out, rather than plugging in points and seeing how it's moving. That takes forever. Okay, number 5. Sketch a slope field for the differential x plus y, window of negative 2, 2 for the x and the y interval. Okay, usually you guys, it'll give you this 1, 2, negative 1, negative 2, 1, 2. -1, -2. Okay, so I've got to get, it's basically asking me for like all these points. That is very annoying. All right. But it's not too bad. I mean, you could make a table or something, but guys, it's actually not too bad because all we're doing is adding x and y, okay? So just think of these points in my head. -2, 2 added is 0. -1, 2 is 1. 0, 2 is 2. 1, I don't know why I did that practically straight up. 1, 2 is 3, and 2, 2 is 4. Okay, now add this. -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1, 2, 3. Okay, -2 plus 0 is -2. -1 plus 0 is -1. 0 plus 0, 1, 2. So there's like a pattern here. -2, -1 is -3. -2, -1, 0, 1. So this is another one where the zeros are coming like right through there. You guys can kind of see that. That's going to be -4, -3, -2, -1, 0. That's a slope field, okay? That looks crappy. Let's look at this other slope field. Okay, so my writing was like pretty bad, right? So let's just look at this slope field. X plus y. That looks better, I think, right? And only, I could change it to only like -2 to 2, but I don't want, whoa, relax. I don't want to mess with that, okay? So that's like kind of what that slope field would look like. Did I get anywhere near close? I mean, sure. Okay. Man. Okay, and then for your differential, sketch a particular solution which passes through the point 1, -1. So all you guys do is you go find your point 1, -1, and then you like follow the lines, right? And I think it kind of goes like that. Okay. Okay, nice. Which of these differentials corresponds to the slope field shown? Okay, so same idea. Now what I'm seeing is, I kind of doubt these are all zeros, but they're very, very small. But at least along here, okay, I'm pretty confident that these are all 0. I can't see it on that line if it's like undefined or something, but I think those are all zeros, okay? Which tells me that, again, when this is the point when, like, 1, 0, 2, 0, 3, this is the point when x is 0. It's telling me that when x is 0, the slope is 0, okay? When x is 0, that's 0, yes. When x is 0, that's 0, yes. X is 0, that's 0. When x is 0, that's 0. Well, that was dumb. Of course, none of those really helped me out. All right. Now, the point, let's compare a couple points. The point 0, no, the point 1, 1 has a very, very flat slope, whereas the point 3, 1 has like a very big slope. So maybe this is another way you could do this, so maybe I'll try these. Okay, the point 1, 1 has a very flat slope. It's not that one. Point 1, 1 has a very flat slope. Could be that one. Point 1, 1 has a flat slope. Nope. Point 1, 1. Okay, so it could be A or D. Now, the point 3, 1 has a very, very large slope, a very steep slope. The point 3, 1 would be 9 over 3, and the point 3, 1 would be 27 over 3. So I'm kind of leaning toward D because it's a huge slope, but they both have pretty big slopes, right? So the only difference is it x squared or x to the third? Well, from what I can think of, x squareds, you guys, and x to the thirds differ when x is negative, so I think I should actually go look on this side. In fact, maybe I'll look at this point right here. Maybe I'll look at the point -1, 0, okay? So I've got it narrowed down to 2. Now, -1 squared is 1. 0 plus 2 is 2. That is not a slope of a half. But over here, -1 to the third is -1, and 0 plus 2 is 2. That does look like the slope of -1/2, so I'll go with that one. So again, I had to try a bunch of different things on there. If you guys could see it, faster, then that's great. Okay? All right, let's take a look at number 8. Okay, it says if the point 2, 6 is a point on the solution curve of the differential y plus x y prime equals 5, determine the concavity of the solution curve. All right? Concavity, right? Well, this time I'm actually going to go ahead and find my second derivative, because second derivative tells me concavity. Okay? Let's first just solve for dy dx. It's pretty easy to solve for dy dx on this. I have xy prime equals 5 minus y. So y prime is 5 minus y over x. Okay? So that's y prime. So now I got to find y double prime, my second derivative. All right? Now this is implicit differentiation. Okay? So I got to go derivative of the top times the bottom. Derivative of the top is a negative 1 dy dx. Derivative top, bottom. Minus the top times the derivative of the bottom, which is 1 over the bottom squared. Okay? Now, this has a dy dx in it. And I actually want to replace that with this, because this is dy dx. This is y prime. So I'm going to replace that right there. I don't really care about the negatives at the moment. So it's negative 5 minus y over x. The whole thing is negative, times x. And then 5 minus y over x is 1 over x squared. Now, I want to plug in the point 2, 6. So I'm going to plug in x is 2, y is 6. So let's see how ugly this is. Negative, okay, 5 minus 6, that's negative 1 over 2 times 2, minus negative 1 over 2 times 1 over 2 squared. Okay, my goodness. All right, those 2's cancel out, so that gives me 1 plus 1/2 over 4. Since y prime is positive, at that point, y is concave up. Okay? Because that is bigger than 0. It's positive, it's concave up. All right, nice. Get back over here. Wait, no, I didn't want to do that. View it on the other side. Okay, cool. Okay, here's another differential we're going to solve. Okay, the differential equation is dh dt is t squared over h squared. Define an expression for h of t if h of negative 2 is 3. Alrighty, here we go. Separating out the variables, bring that up, okay? H squared dh equals t squared dt. If I integrate both of those, that's h to the third over 3 is t to the third over 3 plus a constant. I'm going to go ahead and multiply everything by 3 so that I have h to the third is t to the third plus a new constant, right? Call it C1, C2 if you want, or just, call it a new constant. Now, right here, it says if I plug in negative 2, I should get 3. So if I plug in negative 2, I should get 3. So 27 equals negative 8 plus c. So c is 35. Okay, back up to here. Nope, that was not where I did it from. Back up to here. H to the third is t to the third plus 35. And then I'm just going to cube root both sides. Okay, so h is the cube root of t to the third plus 35. Okay, so that's what I get for number 9. All right. Which of the following is a solution? Now, you can't really separate variables on this problem, so here's how I would do this one. Okay, for each of these, I'm going to go ahead and I'm going to find y prime, all right? For this one, y prime is e to the x plus 2e to the negative x times the negative. So I'm just going to move the negative out there. This one, y prime is 1/2 e to the x, and then 2e to the negative x times the negative, which turns out to a positive. For this one, y prime is e to the x, 3e to the negative x turns that to a positive. And then the fourth one, y prime is 1/2 e to the negative x, put a negative on there, and then 3e to the x. Now, you guys, what this is saying is for which of these does y plus y prime equal e to the x? Okay, I don't want to rewrite all this stuff, so look, I'm just going to take those and add it. Boom, boom, 2e to the x. So it's not that one. All right. My eraser's too big. Okay. Now I'm going to take those and add those. Boom, boom. 1/2 e to the x plus 1/2 e to the x is 1 e to the x. So I think it's that one. Let me add those. Boom, boom. That gives me 2 e to the x. And then let me add those. That actually cancels out, and that gives me 6 e to the x. So it has to be b. So sometimes if we can't solve the differential, we're going to do it like that. Okay? Let's see. I'm going to go kind of halfway through here. We're on number 10. Okay, cool. Let's go a couple more problems. Okay. The rate of coal production, R of T, from a coal mine was 2,000 tons per year at the beginning of 2000. By 2006, it had decreased to 100. Okay, hold on. Okay, so the year 2000, it was 2 tons. In the year 2006, it was 1 tons. The mine will be profitable until less than 200,000 tons of coal produced per year. Assuming the decline in the amount of coal closely models the equation of exponential decay, find the following. Okay, you guys, so the equation is y, gosh darn it, stop it. Y equals CE to the KT. All right. Find, for the particular equation, find the amount of coal mined per year. Let T equals 0 for the beginning of the year. Okay, so check it out. This is times 0, and I got that. This is times 6, and I got that. Okay? Now, you guys, at times 0, anything to the 0 is 1. So at times 0, it tells me that C is 2 million. All right? So that's good because it's at times 0. So my equation now says y equals 2 million e to the kt. Okay, now I'm going to use these points to figure out what k is. All right? Y is 1,200,000 e to the k times 6. Okay? On my calculator, let's go through the steps I'm going to do on my calculator. Gosh, hang on, I gotta make this a little smaller. Get on the screen. Okay, so let me write my steps, but then I want you to follow them on the calculator. I'm going to divide by 2 million, and I'm going to get something. And then I'm going to ln both sides, and I'm going to get something. And then I'm going to divide by 6. Okay? So those are the steps I'm doing. Let me just go do it on my calculator. All right, so I have 2, 1, 2, 3, 4, 5, 6 divided by 1, 2, 1, 2, 1, 2, 3. And I got 1.666 repeating. Okay, so that's what goes here. Now, without rounding, I wanted to take the ln of both sides, right? So I go, this is what you do on your calculator, guys. You go ln of answer When I do that, I have no round off error. Okay, I get 0.5108. Okay, so if I come over here, for this next step, I get 0.5, whatever the heck it was, 108. And then I want to divide that by 6. And so I just go answer divided by 6. All right. And for K, I get, let me see what it was. Oh, like I can read that. 0.085137. Now, I know I'm going to have to use that for the rest of the problem. So guess what I'm going to do, guys? It's this little store button. I'm going to store that in alpha K because I know that's a perfect not rounded answer, and I'm going to use that for the rest of the problem. All right? So part A said to find the equation. So the equation is y equals c e to the k t. All right, you can go past those decimals. Remember, I have that stored exactly. And in fact, if you say let k equal that, you actually could just write k on the AP test if you wanted to. Okay? Okay, nice. Part 2. What's the half-life from the production of coal from part 1? Half-life. Guys, half-life means how long does it take to get to half of what it does. All right, look at this equation. If I start at 2 million, it's for part B, and I want to get to my half-life, the half of 2 million is 1 million. I'm going to just write e to the kt because I know what k is. And so when I divide that over, guess what I get? I get 1/2. That's how we get half-life, okay? ln both sides to get rid of that. So the ln of a half is kt, so t is the ln of a half divided by k. Okay, so let me come out over here. Let me go the ln of 1/2, that's my half-life, divided by alpha k. Boom. Oh gosh, this is actually fine. I just realized something though. 8.1414. You guys realize it too? K should have been a negative number because it's decreasing. I'm going to get a negative number for that. Let's go back and check. Oh, I know why. Because like oh no, did I do this whole thing wrong? No. Oh, flux. I divided 2 million by 120. Hopefully it's just a negative of that, but I definitely did this whole thing wrong. All right, let's see. 1200000 divided by, I'm going back to part A real quick, equals ln of that equals divided by 6 equals, oh bless my soul, okay, it's just the negative amount. So I divided it wrong at first, but you guys, it's decreasing. K should have been negative. It's minus 1 point from me if everyone is keeping track. And then if K is negative, that ends up bringing the time to positive. So it's 8.1414 years. Good heavens. It's been a long day. All right. When will it no longer be profitable to mine coal? Okay. This is for part C. I started at 2 million. As long as I am above 200,000, it's still profitable. Okay? E to the K, which is now negative T. All right? And I'm just going to solve that again, you guys. So let's go over the steps, okay? Divide both sides by 2 million. And that's e to the something. And then I'm going to ln whatever I get, and that equals k times t, and then I'm going to divide by k. All right, hopefully you guys get that. Okay, so check it out. So I'm going to do this time, so I can do it right. 2, 1, 2, 1, 2, 3. Divided by, hello, get back here. Divided by 2, 1, 2, 3, 4, 5, 6. What's that? ln both sides. Get rid of the e equals that. Divide by k. Now remember how I messed up and I didn't have my k as a negative? Can you guys forgive me and can I just put divided by k? But I put a negative in front of it. Okay, so my mine will be profitable for 27 more years. 27.045 to be completely accurate. Okay, 27.045 years. That entire problem, you guys, I've done in Algebra 2. That's actually not even a calculus problem. It's a pain, but we didn't take any derivatives or integrals. That's not really a calculus problem. Okay? Write a sentence telling what this represents, 0 to 6. Oh, I love this so much. Okay. Do you guys remember, like, start plus accumulation? So if I started at that and I added accumulation, it would equal whatever r of 6 is. Okay? So that's the accumulation part. So that is basically going to be the total amount of coal produced from year 2000 to year 2006. So I started with a certain amount, the total amount of coal produced, and then that's what I would get. All right? Fun. Oof. Okay. Approximate the value of the integral using the table at the right. Our values are to the nearest 1,000 tons per year. So it dropped off an extra 0, 0, 0. Use a midpoint sum with 3 subdivisions and a trap with widths of 1, 2, 3 in that order. Guys, it does not tell me I have to solve it, so I'm just going to set it up. Okay. Midpoint sum, base times, oh wait, sorry, midpoint sum, 3 equal subdivisions. So the midpoint sum goes that, that, that. So it's the base of this rectangle for midpoint. The base of that rectangle is 2, and the midpoint is at 1837. The base of that rectangle is 2, and the midpoint is 1549. And the base of that rectangle is 2, and the midpoint is 1307. And am I going to add all those up? No, because it didn't tell me to. Okay? And then a trapezoidal approximation, but this it wants me to do widths of 1, so that's 0 to 1, 2, so that's 1 to 3, and then a width of 3 is 3 to 6. Okay, so those are my 3 trapezoids, if you guys see them. It goes like this: 1/2 base sum of the heights. 2,000 plus, can I write any smaller? 1837. And then it's the next one, 1/2. This one has a base of 2. I'm going from 1 to 3. Sum of the heights. Those are the heights. 1837 plus 1549. And then 1/2, base of 3, and then sum of the heights. 1549 plus 1200. Okay, that's ugly enough, but whatever. There you go. Use your calculator to find the actual value of problem 12 to the nearest 1,000 tons. The integral from 0 to 6 of this equation that I had. Here's this equation that I had. That was my equation, right? So let's see here. The integral from 0 to 6 of this equation I had. Now they put it in hundreds of thousands, so I only have to put 2, 0, 0, 0. They took off those extra zeros on the end. E to the k, I'm not going to type it again, but I do remember that I accidentally didn't make my k negative, so that's annoying. E to the k t, where t is x, dx. So between 0 and 6, you know how much coal we got? Dun, 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 dun. We got 9396, like 100,000 or whatever, okay? 9396, right? So then I just go, okay, yeah, I got like 9396. I guess it could round up, but that's fine. 1,000 tons, okay? And if you add up those other numbers, they're like somewhere near that, but whatever. All right, whew, we got that out of the way. Oh, beautiful. Let's do 15 and 16, and then we'll just do a little review on the next video. Here we go. Which of the following shows a correct solution curve containing the point 0, -2 for this slope field? 0, -2, are my slope fields all the same? Okay, so just figure out what kind of goes with the lines here. 0, -2 is here. Let's see, guys. This is like all over the place. See, if I, okay, try to pretend like that line isn't there. See how it's going like that, and then like that. Okay. Oh, except for it goes 0 right down there. All right, so let's try this again. It goes 0, -2, so it goes up there, goes down here, goes across, then around there it goes that way and that way. So we want the slope to be 0 there, and we want it to come to there. So that looks like B. Okay, that looks like B. This isn't; those other ones aren't even really following the slope fields. All right, and then for 16, which of the following shows a correct solution curve containing the point 3,2. Now notice that this axis is all undefined, so immediately guess what? I'm already thinking it's that, because when it's undefined, you're not allowed to go through it. So for the point 3,2, yep, sure enough, it looks like that, and it goes to there. Okay, you can't go through an undefined on a slope field. All right. Nice. The rest of this just looks like a review, and I will do these review problems with you, but let me do them on the next video because this one's already a little long. So, there you go.